Good morning. Today's lecture will cover the topic of rate of reaction on chemistry, no levels chemistry, because this topic is quite interlinked with the topic of enzymes in biology. So, in order for you to have a deeper, wholesome understanding of the topic, I'll be covering the essential concepts in this topic. So, firstly, we'll be determining the factors which control the rate of the reaction. So, what is it? How is the rate of the reaction measured? The rate of the reaction can be measured by two things. Firstly, how quick a reactant is being used up, or secondly, how quick the product is being found. Now, you need to understand that there are two types of reactions: reversible reactions and irreversible reactions. Reversible reactions are always represented by two arrows, where one going in the forward direction and the other can be going in the backward direction, whereas irreversible reactions always proceed in the forward direction, and they are represented by a single arrow. Now, the factors which are affecting the rate of the reaction are temperature, concentration, pressure. Now, you need to know, it is frequently asked in the papers that the factor of pressure is only, does only, I repeat, it only affects gases. The surface area of solids, which I'll be giving examples of how we use this factor in the topic of enzymes as well, and the use of catalysts once again, which we covered in biology. So after we've known that how the two factors which determine the rate of the reaction, how do we measure how fast and the rate of the reaction is proceeding? For example, this is a reaction going on in a conical flask. So obviously there will be, you can see these bubbles which are being emitted. So these bubbles will go into the gas syringe. Often at times, the total capacity of a gas syringe is asked. So you need to know that a gas syringe only occupies 25 centimeter cube of gas, and it cannot measure gas more than it. So as you can see that the gas will go from this pipe into the gas syringe, and so simultaneously the amount of gas being which is being stored can be measured over here. So, as I said earlier as well, that the rate of reaction is calculated by the amount of reactant being used divided by the time taken. So now I will tell you that how these factors affect the rate of the reaction. Firstly, you need to know that how the rate of the reaction proceeds. For a chemical reaction to take place, the faster the collision between the molecules occurs, the faster the rate of the reaction occurs. Now, there is a concept known as activation energy. Activation energy is, for example, that there must, I'm just giving you an example that for a reaction to proceed, if there's, for example, 10 joules of minimum amount of energy which needs to be present. So if you basically apply 8 joules of energy, there's still 2 joules of energy which need to be applied, and so the reaction won't proceed no matter if you applied 8 joules of energy, that energy will go waste. So the activation energy is the minimum amount of energy required for the reaction to proceed. This is an extremely important concept for you to understand. So for an example, what happens when the temperature is increased is that when the temperature is increased, this is the example. The red line shows the graph of a normal reaction. The blue line shows the graph when the temperature is increased. That when the temperature is increased, the particles gain more kinetic energy, and as the particles won't gain more kinetic energy, they collide with each other more frequently, and they gain energy above the activation energy. So once they achieve energy which is above the activation energy, the reaction proceeds smoothly. Secondly, changing the concentration or pressure. Now I've repeated before that this particular factor is only for the gases, but the greater the pressure is, there are more reactive particles which are basically in a specific chamber. So you need to note that, for example, if there is a sealed chamber and you increase the pressure, there are more specific. What is our aim? Our aim is to make the collisions appear more frequently. So when there, for example, there are five persons in people in a room, and in another case there are 50 people in a room. So obviously, the room in which there are 50 people, there will be more collisions. So similar is the case with particles. Now, the third factor is changing the particle size. If we break down the particle size or crush, for example, we crush a substance, its surface area is increased. Now, when a surface area is will be increased, there will be more particles which will be opposed to the reactant, and thus there will be greater collision. Thus, the rate of the reaction will be increased. I've already basically repeated to you that how changing the temperature increases the activation energy, and this increases the rate of the reaction. Now, the most important concept in this topic is is the use of a catalyst. How does a catalyst affect the rate of the reaction? Now, a catalyst is a substance which helps to lower the activation energy without being used up or consumed in the reaction at the end. What it does is, for example, I give you the example that we apply 8 joules of energy, and the amount of energy required for the reaction to proceed is 10 joules of energy. So what a catalyst does is that it decreases the activation energy by, for example, it will be decreasing the activation energy by 3 joules of energy. So now the activation energy required for the reaction to proceed will be 7 joules, while you will be applying 8 joules. So obviously the reaction will proceed. So in biology, the same concept is applied, and enzymes are required as a catalyst. Enzymes are used in various chemical reactions as a catalyst. Now, their efficacy in industrial uses, you will be studying, for example, the catalysts are used in the manufacturing of fertilizers industry, which requires huge amounts of products to be made. So what they do is that they reduce the cost and help to increase the efficiency. I'll be giving you examples of the catalysts which are being used. For example, the palladium catalyst, thallium catalyst, and iron as a catalyst in the manufacture, and iron as a catalyst. Now, the for specific industries which will be studying about these will be covered in the next lecture. Thank you.